Okay. So I want all of you to enter Classtime, classtime.com. You should type, and then there it will ask for code. So this is the session code 4WGQG7. Okay, add this, supply this code and press enter. You will get this kind of a screen. I have given 3 questions first for you to solve. So again, for those of you who have joined late, I'm repeating. For those of you new to Classtime, go to classtime.com, classtime.com for live quiz. Classtime.com, enter into classtime.com, and here you see uh, join through code. So put this code 4WGQG7 and then enter. You will get this. So please join with your correct name and then start marking the answers. So I'll give you 6 minutes time. Starting now, 6 minutes, just attempt these questions. Okay, another few seconds. Maybe another 20 seconds. I'll get 7 minutes.
So you're on mute.
I'm sorry. Now are you able to hear? So
Yes.
these practice questions. Now we'll start the first one. So this is the question. Find the value of this integral. So this is simple, evaluation by reducing into standard form. So integral 0 to pi by 4. Cos square is 1 plus cos 2x upon 2. This is the integral cos square. Now this is integral 0 to pi by 4 half plus half cos 2x dx. Now integral of half is x by 2 plus integral of cos is sine. So sine 2x upon 2. Cos 2x, integral is sine 2x upon 2. But here 2 is already present, so it is 4. Sine 2x upon 4. So applying the limits from 0 to pi by 4. So first you get pi by 4 by 2. And this is sine of 2 into pi by 4 is pi by 2 upon 4 minus, when you substitute the lower limit, 0 by 2 minus plus sine 0 is 0 by 4. So we get pi upon 8 plus 1 upon 4. So pi upon 8 plus 1 upon 4. So this is the answer. So that was simple, very, very simple. The second one, the second question. This is extremely simple. It's not a difficult question at all. Question 2. So find the value of this definite integral. So we can see here that sine 2x is an odd function. And cos x or 1 plus cos x is even function. So the product will be odd, or the quotient sine x upon sine 2x by 1 plus cos x is an odd function. And minus a to a odd function integral will be 0 using the property. Integral of minus a to a f of x dx is equal to 0 if f is odd. So answer is 0 straight away. Okay, that was very simple. Now, so we just had to use the property. You didn't have to do any evaluation. The next one. So evaluate the following integral. Integral 0 to 1 x log x dx. So this doesn't have a any standard property. Now without using the property, you will have to do this. We'll have to use integration by parts. So x is algebraic, log x is logarithmic. So in I late, logarithmic comes first, then algebraic comes next. So this becomes the first function, and this becomes the second function while integrating by parts. So we get integral of first function, that is log x as it is, into integral of the second. Integral of second function is x. Its integral will be x square upon 2 from 0 to 1 minus integral 0 to 1 derivative of the first function. So derivative of log x is 1 upon x into integral of the second, x square by 2 dx. So I'll just not apply the limit because log x is not defined at x equal to 0. We'll have to use limit. Now this is x upon 2. Integral will be x square upon 4, 0 to 1. Now this is, let's apply limit for this, upper limit and lower limit. When we apply upper limit, 1 by 2 log 1 minus limit x tends to 0 plus x square by 2 log x, because log 0 is undefined, minus of, now let's apply the upper limit for x square by 4, substituting 1 in place of x, 1 upon 4, minus applying the lower limit 0 upon 4. Now, so this is 0 minus, now we'll have to use L'Hospital's rule. Log x by 2 into 1 upon x square minus 1 by 4. Let's apply L'Hospital's rule. differentiate numerator separately and the denominator separately. So 2 into minus 2 into 1 upon x cube. So you get limit x tends to 0 plus x square minus x square by 4 minus 1 by 4. So this limit will be 0. So answer is minus 1 by 4. Answer is minus 1 upon 4. Okay. So these were the 3 questions. Now I'll give the next set of 3 questions. Let us start. The 4th question. This is the question here. Give the answer. I'll give you 2 minutes time for this question. Start. Are you accessing the class time? No one has answered till now. Okay, good. Another half a minute. Okay. That's not a difficult question. So question 4. The question is evaluate this integral. Now, when it comes minus a to a, immediately it should strike to us that we can use the properties. So the same property which we used earlier, integral minus a to a f of x dx will be 2 times integral 0 to a f of x dx if f is even, and it is equal to 0 if f is odd function. So now sine x is an odd function. Okay. Sine raised to the even power. Even as soon as you raise it to the even power, it becomes an even function. However, an odd function raised to an odd power will be an odd function, right? What is odd function? F of minus x is equal to minus f of x. Okay. So f is odd. And even function means f of minus x is equal to f of x. So f is even. All right. So sine power 6x will be an even function. Sine power 7x will be an odd function. So this we can split into two integrals. Integral minus a to a sine x raised to the power 6 dx plus integral minus a to a sine x raised to the power 7 dx. So this is odd. So this will go to 0 because it's an odd function. And this will become twice of integral 0 to a sine x raised to the power 6 dx. So look at the options. So the first option here, 2 into 0 to a sine x raised to the power 6 dx. This is the answer. Okay. But it was not a difficult question. Now, next, I will give the fifth question. Go check in the class time. Okay, this one definitely you should do it in, I would say, less than a minute. Please answer. 1.5 minute. Another 30 seconds. Okay. Answer is pretty straightforward. X is odd, cos x is even. So when you replace this x by minus x in this expression, cos of minus x is cos x, and this becomes minus x. So it is minus x cos x. So product of an odd function and an even function is an odd function. So therefore, the integral minus a to a f of x dx will be 0. It will be 0. Okay. So that's how we do this. Next, the sixth question. Look at the sixth question. Okay, I'll give you 3 minutes time for this. Should be able to do it in 2 minutes, but I'll give 3 minutes. Okay, only 2 students answered. It was very simple question. And this question, if you go back to your CBSE textbook or your intermediate textbooks, state level or CBSE level, and 12th class, you will see this integral there. It is not difficult. And this question, all the questions that I'm giving here are previous gate questions. Okay, I'm selecting from that pool only. So you can see they were very simple questions. It is not difficult. So this was question 6. So I is integral 0 to a under root of x upon under root of x plus under root of a minus x. Now we use this property, integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx. Okay. Therefore, I will be integral 0 to a. Instead of x, we write a minus x upon, instead of x here, a minus x plus, instead of x here in the second term of the denominator, we write a minus x. So under root of a minus of a minus x. So we get integral 0 to a under root of a minus x by under root of a minus x plus under root x dx. So this is first integral. This is second integral. Both are equal. So add 1 plus 1. Why am I adding? Because I see the common denominator. I can add. And when I add, the numerator will be equal to the denominator. This is the first term. A minus x dx. And this will be the second term. So denominator is the same. And when you add, the numerator also becomes the same. So what you get is 2I is equal to 1 dx. So integral of 1 is x. And this is a minus 0. So I will be equal to a upon 2. Okay. I will be equal to a upon 2. To solve problems like these, I have given, after we discussed property 4, I have given a number of equations, sorry, number of questions relating to property 4. So we should just practice that. Property 4, yeah, these models 2b, 2c, 2d, 2e, 2f, 2g. If you do these, then you will get an idea how to do the one which we have done just now. Okay. So that was about some basic problems on uh, definite integrals. Now you can see these are the types of questions that are coming in GATE. They're not difficult. Just that you have to be practiced with the properties. You have to remember the properties and apply. They're not difficult questions. All right. So today's topic, now we'll move further. So now today we move on to an important topic, improper integrals. And after we do improper integrals, oh, sorry, let me turn on my video. Just a second. So today's topic is on improper integrals. And their convergence and divergence nature. So what is the definition? Let's look at it. The integral a to b f of x dx is called as an improper integral if there are two conditions. If either a or b or both are infinite. That means the limit either at least one of the limits is infinite. Second, so either the first condition holds or okay, or f of x has an infinite discontinuity f of x has an infinite discontinuity at one or more points in the closed interval AB. Infinite discontinuity means the function goes to infinity. Okay, if the function goes to infinity, then it is called as the infinite discontinuity. So this is the definition of improper integral. So within this, so if it is due to the limits, that limits are going to infinity, we call it as the improper integral of the first kind. Okay, it's improper integral of the first kind if either a or b or both are infinite. So examples, integral minus infinity to 0 e power x dx. This is an example of an improper integral. Next, another one, integral 0 to infinity e power minus x dx. This is also an improper integral. So in the first case, a was going to minus infinity. In the second integral, b is going to minus infinity. Now we can have both a and b. Third example, minus infinity to infinity dx upon 1 plus x square. So this is improper integral of the first kind. When one of the limits or both of the limits go to infinity. And the second one is called as the improper integral of the second kind. Improper integral of the second kind. Okay, this is if f of x is having an infinite discontinuity. Infinite discontinuity means that function value goes to infinity at that point. Infinite discontinuity at, okay, at x equal to a, or at x equal to b, or at x equal to c, where c belongs to open interval ab. Okay, so then integral a to b f of x dx is an improper integral of the second kind. Okay, this is the definition. So examples. The first example is the one which we have solved so many times in our discussion. Integral 0 to 1 log x dx. Why is this improper? As x tends to 0 plus, log x tends to minus infinity. So at x equal to 0, log x is not defined. So there's an improper integral. Next, another improper integral, integral 0 to pi by 2 tan x dx. Why is this improper? Again, at pi by 2, tan x is not defined. All right. So as x tends to pi by 2 minus, tan x tends to plus infinity. Okay. So basically it is at least one point which is outside the domain. So here we see the point A, the lower limit, at the lower limit function is not defined. In the second example, in the upper limit, at the upper limit, the function is not defined. Then third, integral 0 to 2 dx upon under root of 4 minus x square. Now here, um, as x tends to 2, the function goes to infinity. Because function is not defined at x equal to 2. Just close to 2, the denominator goes to 0, close to 0. So the reciprocal will be infinite. Now, another one in between, let us say integral 0 to 2 dx upon x minus 1 to the power 2 by 3. Now at x equal to 1, the integrand, the function, has infinite discontinuity, again like the previous cases. Okay, so this is how these are the categories of improper integrals. So when we see the improper integrals, we need to be careful how to solve. So they are of two kinds. Either the limits go to infinity or the function itself goes to infinity. When limits go to infinity, it is the first kind. When function goes to infinity, it is the second kind. Now we talk about the convergence. Convergence or evaluation of improper integrals. and their convergence and divergence. We'll discuss what is convergence and divergence. Now, so the improper integrals of the first kind are evaluated as follows. So, if the function f of x is continuous on closed interval a to infinity. So, integral a to infinity f of x dx. So, this is an improper integral. How do we evaluate this? We write this integral as integral a to b f of x dx and apply the limit b tending to infinity. So first we assume some variable value b as the upper limit, and we evaluate the integral, substitute the upper limit and the lower limit, and then make the upper limit tend to infinity. This is the way we evaluate. Now, if f of x is continuous on minus infinity to b, so we have integral minus infinity to b f of x dx. So how will we evaluate? We'll write integral a to b, and we evaluate integral a to b f of x dx, and then apply the limit a tends to minus infinity. Okay. Next. Now, if f is continuous on the entire set of real numbers. Okay. However, we need to evaluate integral minus infinity to infinity f of x dx. When we need to do this, what we'll do, we will take an intermediate value c, some value c in some real number between minus infinity to infinity, and then do c to infinity. Split the integral this way. Now we can apply the first part, integral a to c f of x dx, limit a tending to minus infinity, plus limit b tending to infinity, integral c to b f of x dx. So this is how improper integrals of the first kind are calculated. Now, if in the above cases the limits on the right hand side, the limits on the right hand side of the equations exists and are finite, then we say that the improper integral converges or is convergent. So the improper integral is convergent. Okay. Now, if the limits on RHS on the right hand side go to are infinite or do not exist, okay, then we say that the improper integrals or the improper integral diverges or is divergent. So convergent means you get a finite value, unique finite value, that is convergent. If we get infinite, the limit goes to infinity, then we say it is divergent. Okay, or the limit oscillates between two values, it is divergent. So let's evaluate some improper integrals of this type, of the first kind. Okay, where one of the limits goes to infinity. Let's evaluate them. Integral minus infinity to 0 x sine x dx. Now let's evaluate this. So this is I. So let's solve this. So this I we will write as integral a to 0 limit a tending to minus infinity x sine x dx. Okay. Now we'll have to do integration by parts. I late ATE algebraic and then trigonometric. So trigonometric will be the second function, algebraic will be the first function. So integrating by parts. Limit a tends to minus infinity. The first function into integral of the second. Integral of the second is minus cos x. First function is x. Second function is sin x. Integral of sin x is minus cos x minus integral of the derivative of the first, that is 1, into the integral of the second. I'm not applying the limits now. I'll apply at the end after I evaluate the full indefinite integral. Now this becomes cos x, minus and minus becomes plus. So integral of plus cos x, and cos x is sin x. So we get minus x cos x plus sin x as the indefinite integral. Apply limits from a to 0, the integration limits. So substitute 0, we get minus 0 into cos 1, cos 0 is 1, plus 0 minus a cos a plus sin a. So what we get now we get limit a tends to minus infinity. We get a cos a minus sin a. Now, we need to apply the limits as a tends to minus infinity. Sin a and cos a, okay, take values between -1 and 1. They take values between -1 and 1. So this will be a small fraction. This portion will lie between -1 and 1, minus sin a. Okay. So this will not go to infinity. Now cos a will also lie between -1 and 1, but a goes to minus infinity. Now when a goes to minus infinity, if cos a is positive, this limit goes to minus infinity. If cos a value is negative, this is going to minus infinity into a minus sign. You will get plus infinity. So this I can take values either minus infinity or plus infinity. So the limit itself doesn't exist. The limit itself does not converge to one single value. It doesn't even converge to plus infinity. It is oscillating between minus infinity to plus infinity. So therefore the integral is divergent. So it does not exist. You don't get a value for this integral. So the integral diverges. Next, let's take an example. Clear? Is this explanation clear? So we did integration by parts, solved the indefinite, found the indefinite integral, applied the limits of integration, and then after that applied the limit as a tends to minus infinity. So the improper integral is divergent. Now let us look at this one. I is integral minus infinity to infinity dx upon 1 plus x square. Now, as x tends to infinity, the denominator goes to infinity. So the integrand goes to 0, but these are the limits. So now how to do this? The first thing is, I see that the integrand is even. 1 by 1 plus x square is an even function. So therefore, I from minus a to a, we can write this as twice of 0 to infinity dx upon 1 plus x square. 0 to infinity dx upon 1 plus x square. This is the, because it's an even function. Otherwise, we could have done from minus infinity to 0 and plus 0 to infinity. We could have split into two integrals. This is easy one. Now we know that integral of 1 plus x square is tan inverse x. So of course, first before I do that, I have to write limit b tending to infinity 2 into 0 to b dx upon 1 plus x square. So we get limit b tending to infinity 2 into tan inverse x, applying the limits from 0 to b. So we get limit b tending to infinity 2 tan inverse b. And as b tends to infinity, tan inverse of infinity tends to pi by 2. So 2 times pi by 2, the answer is pi. So we say the integral converges to pi. The improper integral converges to pi. So this was when the limits of the improper integral, either one of them or both of them are going to 0. So this was of the first kind. All right. Now next. Now the improper integrals of the second kind are evaluated as follows. Now, so if f has infinite discontinuity, at x equal to a, that is integral a to b f of x dx. Now f of a does not exist, so how do we evaluate? So this we write as limit h tending to 0 integral of a plus h, because a is the left end of the interval, so we can approach from points within the interval. If we are approaching a, it has to be from the right. That's why a plus h to b f of x dx. Or we can also write this as integral x to b f of t dt, where limit x tends to a plus. These are both are one and the same. H tending to 0 or x tending to a plus. To avoid the confusion between the limit x and the integrand variable x, we can replace x by t. So integral remains same. So then we can apply this. So this is how, if at left end there is a discontinuity, this is how we do it. Now, if f of x has infinite discontinuity, at x equal to b, integral a to b f of x dx. So similarly, what we'll get, a to b minus h, limit h tending to 0 f of x dx. Or this is same as integral a to x f of t dt, limit x tending to b minus. Okay. So to the right end of the interval, we will have to approach from the left. This is a, this is b. So it will be limit x tending to b minus, or this is limit x tending to a plus if it is to the left. All right. Now, if there is a discontinuity in the intermediate point, let us see this. If f of x has infinite discontinuity at x equal to c, where c belongs to open interval AB. So some intermediate point. So what do we do? Now, a to b f of x dx has to be written as integral a to c. We have to identify that point of discontinuity and split the integral into two parts. A to c f of x dx and then c to b f of x dx. Then what do we do? Here we write limit h tending to 0 integral a to c minus h f of x dx plus limit k tending to 0 integral c plus k to b f of x dx. Okay, just combination of the previous two integrals. That is what it is. So when there's a discontinuity of the second kind, that is how we evaluate the integrals. Now, if the limits on the right hand side of the above are finite and exist, that means I have a single value. Okay, then the integrals, the improper integrals are convergent. These are convergent. Otherwise, they are divergent. So that is the convergence and divergence of integrals. Okay. So the first one of this type examples, which we have done so many times, we'll do it very fast again. Integral 0 to 1 log x dx. Very simple. At log x, the integral is not defined. So we write limit h tending to 0 integral 0 plus h is 1 log x dx. Integral of log x is, we know, we have done problems. It is x log x minus x. So applying the limits of integration h to 1. So substituting 1 into log 1 minus 1 minus of limit h tends to 0 x log x minus x. Sorry, h log x. Okay, or you can make this h log h minus h. So earlier we did this as limit x tends to 0 plus, and we evaluated this. So this is 0 minus 1, and we'll have to apply L'Hospital's rule here for log h by 1 by h, and the second term, when you apply the limit, it will tend to 0. And by applying the L'Hospital's rule, we get 1 upon h as the derivative of the numerator and minus 1 upon h square as the derivative of the denominator. And when we evaluate the limit, we'll get 0. So the answer is minus 1. Therefore, integral 0 to 1 log x dx is minus 1. It is convergent. It is a convergent integral. So we say the value of the integral converges to minus 1. Okay. So this one we have done very often. Now, let us check this one. Evaluate integral a to b dx upon a minus x square, a minus x the whole square. Okay. Now, the function has, the integrand, that means the function that is being integrated has infinite discontinuity at x equal to a. So we can see that the denominator goes to 0. So what do we do? So we will write as limit h tending to 0 integral of a plus h to b dx upon a minus x the whole square. So this is limit h tending to 0. Now, when we integrate this, we get minus 1 upon a minus x divided by the coefficient of x, that is minus 1. So this becomes plus. So that is the integral. Now apply a plus h to b. So this is limit h tending to 0, 1 upon a minus b minus of 1 upon a minus of a plus h. So this becomes limit h tending to 0, 1 upon a minus b, a cancel, then this minus h into minus 1 becomes plus 1. You have 1 upon h. Now as h tends to 0, the first term is a constant. The second term goes to infinity. So this integral goes to infinity. Therefore, the integral is divergent. The integral is divergent. So that's the second question. Very simple. It's not difficult, just that we need to be careful, and we get the problems on convergence and divergence. I will just give you one more example. Evaluate integral 0 to 2 dx upon under root of 4 minus x square. The general tendency is to write this integral directly, the antiderivative as sine inverse x by 2. But we need to know that at x equal to 2, the integral, the integrand, the function is discontinuous. It has an infinite discontinuity. It goes to infinity. So yeah, so let us do this. We will write as integral 0 to 2 minus h applying limit h tending to 0, integral 0 to 2 minus h dx upon root of 4 minus x square. So this is limit h tending to 0, sine inverse of x upon 2 from applying the limits of integration 0 to 2 minus h. So this is limit h tending to 0, sine inverse of 2 minus h upon 2 minus sine inverse 0. So sine inverse of 0 is 0, and as h tends to 0, this goes to sine inverse 1 minus 0. Sine inverse 1 is pi by 2. So this integrand, this integral converges to pi by 2. Okay. So these are examples. We took two examples on improper integrals of the first kind, and we took three examples on improper integrals of the second kind. So now let us do some practice problems. So again, let's go back to class time. Seventh question. Yeah. If you are able to see the question clearly. Please solve this one. I'll give you 2.5 minutes exactly. These are problems on improper integrals. Go to class time, the same session, 4WGQG7. Some of you have logged off class time. Again, join. Okay, 5 of you, of which 4 of you got a wrong answer. All right, now just look at this. This is apparently very simple looking integral. So in class time, the question number is 7. Okay. Now, the interval of integration is -1 to 1. So the interval of integration is -1 to 1. But at 0, the function is not defined. So f of x equal to 1 upon x square has infinite discontinuity at x equal to 0. Therefore, this integral has to be split like this. Integral -1 to 0. Of course, because of you know even function, we can do it. This is same as twice of integral 0 to 1 dx by x square. Because it's an even function, we can straight away do that. Now twice of limit h tending to 0 integral 0 plus h to 1 dx upon x square. So twice of limit h tending to 0 integral of 1 by x square is -1 upon x. The limits, applying the limits of integration h to 1. So what we get is 2 into minus 1 by 1 minus of -1 upon h as h tends to 0. Limit h tending to 0. So what we get is 2 times -1 plus infinity. So it goes to plus infinity. So integral goes to plus infinity. Let's look at the options available to us. Yes, infinity is available. So this is the correct answer. The mistake we make is if we don't do this, if we don't do either 2 times 0 to 1, we'll get a mistake. Or if we directly apply the integral like this, -1 to 1 dx upon x square is -1 upon x -1 to 1. So take the minus sign out. So 1 by 1 minus of 1 by -1. So we will get the value as -2. This is a mistake. Why? Because there is a discontinuity at x equal to 0. So very simple problem, but this concept is involved. Okay, I hope it's clear. Now next, let's go to the next question. So I've opened out question number 8. So please check. This again an infinite improper integral. I'll give you 2 minutes time. It's simple. Please do so. Good. Many correct answers. All right. So this is a simple question. It's not difficult. So this question 8 from last time. So this integral is simple. S is limit, uh, b tending to infinity, integral 1 to b x to the power minus 3 dx. This is limit b tending to infinity, x to the power minus 3 plus 1 is minus 2 upon minus 2. Applying the limits of integration, limit b tending to infinity, take minus 2 outside, we get 1 upon b square minus 1 upon 1 square, that is 1. So as b tends to infinity, 1 upon b square goes to 0, and this is a constant. So minus 2 times minus 1 is plus 2. That is the answer.
Sir, minus 1 by we need to
Oh,
take
I'm
common.
sorry. I'm sorry. I'm sorry. Got it. This is sorry. This minus 1 upon 2 is the plus 1 upon 2 is the answer. Okay. So this is the answer. All right. So simple. This question was good. Now look at this question. Question 9. This was also given in one of the GATE exams. Which of the following integrals is unbounded? Which of the following integrals is unbounded? That means which of these limits is going to infinity? That's what we need to do. Okay, 2 students, 3 students, 4 students answered within 2.5 minutes. Okay, good attempt. Now let's look at the solution. So this is question 9. Now the first integral, I'll say I1, is integral 0 to pi upon 4 tan x dx. Integral of tan x is log mod secant x, and secant x is positive in this interval of integration, so no problem. Now this is log of secant pi by 4 minus log of secant 0. Secant 0 is 1 and secant pi by 4 is √2. So log 1 is 0. So you get half log 2. So it is a convergent integral. Second, integral 0 to infinity dx by 1 plus x square. We did this. This is tan inverse x. As this is approaching infinity, this will not exactly be infinity, but just for shortage of time, this is an improper integral. So this is pi by 2. So again, it's convergent. The third one, we'll have to do integration by parts. So exponential is the second function by default. The first function is x. So first function, now when we integrate first function into integral of the second minus integral of the derivative of the first into the integral of the second. Applying the limits at the end. So we have minus x e power minus x plus integral of e power minus x is e power minus x into minus 1. So you get a minus sign here from 0 to infinity. So as x approaches infinity, e power minus infinity goes to 0. And this goes to infinity, but you can see with L'Hospital's rule, you can check it, that this this value will go to 0, and this is going to 0, minus of, substitute the second one, it goes to 0, minus 1. So this is also bounded. So 3 are bounded. So answer is the fourth one, but we'll check the this integral. This is log of 1 minus x upon minus 1. 0 to 1. Now this 1, we have to see, we can write as like this, limit x tending to 1 minus log of 1 minus x minus 0. When you substitute x equal to 0, log 1 is 0. So this will go to 0 plus. So this goes to minus infinity. So this is plus infinity. So that which is unbounded is this integral. This is the answer. Okay. last of the practice questions. This is not on improper integrals, by the way, but just for practice, because I've given it, let us complete. Okay, I'll not give you a hint. Try it. Okay, not even one in 3 minutes. All right, I will solve this. This is based on Valley's formula that I discussed yesterday. See, Valley's formula is valid from 0 to pi by 2. Now you observe this. We can write 3 theta, substitute 3 theta as say alpha. So 3d theta is d alpha. Therefore, I now let's see theta and alpha limit. When theta goes to 0, theta is 0, alpha is also 0. And when theta is pi by 6, alpha, which is 3 theta, will be pi upon 2. Okay. So I is integral 0 to pi by 2 cos power 4 alpha into sine cube 2 alpha times d theta is 1 upon 3 d alpha. Okay, we have converted this. Now write sine 2 alpha as 2 sine alpha cos alpha. So what do we get? We get 2 cube comes out. Then we have integral 0 to pi by 2. 2 cube by 3 comes out. Then we have 0 to pi by 2 sine cube alpha and cos to the power 7 alpha. This is now in the values formula form. So this is 8 upon 3 times 8 upon 3 times. This is 3 minus 1, that is 2. So it ends at 2 here, multiplied by this is 6, 4, 2. Denominator is 10, 8, 6, 4, 2. So we cancel 642, 642, and 8 cancels, and 2 cancels 10 5 times. So we are left with 1 upon 15. So that is the answer. 1 upon 15. Okay. So 1 upon 15 is the correct answer. So already it's time. I actually wanted to do important application of integrals to definition of gamma function and beta function that is very often used. So maybe it will take to 20-25 minutes. I'll do it in the next class. So in your assignment that I've given, there are 3 questions on gamma functions. So you will come across that. It will be difficult for you to solve the integral, so you leave them. Other than that, 22 questions out of 25, you should be able to do it. So you please practice the assignment. I will release the test up to this point. Next, following beta and gamma functions, we will have application of integrals to finding areas and volumes of areas of plane figures, surface areas of solids, and volumes of solids using integrals for the first function of using integrals for functions of a single variable only. So we will do that. So that will take another 2 sessions minimally. So by the next weekend, we will complete application of integrals. And we get a lot of questions on that section. Application to finding areas and volumes of figures. All right, any questions you have?